What's up, guys? In this episode, I'm going to prepare you for using equilibrium conditions in statics. There are two skills you need to have: decomposition of forces and moment of forces. Let's start with decomposition of forces. But first, let's review trigonometry quickly. In any right triangle ABC with a given angle theta, sine of theta is equal to the opposite side divided by the hypotenuse. Cosine of theta is equal to the adjacent side divided by the hypotenuse. Tangent of theta is equal to the opposite side divided by the adjacent side. In decomposition of forces, the resultant force is analogous to hypotenuse in a right triangle. Its x and y component of forces are analogous to the other two sides. Most of times, sine and cosine are good enough to handle all different cases. Here are my 4 tips for you. 1. Multiply sine or cosine to determine x or y component. 2. Divide it by sine or cosine to determine resultant force. 3. Use sine when involved side is opposite to the given angle. 4. Use cosine when involved side is adjacent to the given angle. Let me show you some examples and see if you like my tips. Example 1. The resultant force is given as P equals 100 Newton. Find x and y component of P. X component of P is adjacent side. Use tips 1 and 4. Y component of P is opposite side. Use tip 1 and 3. Example 2. Y component is opposite side relative to the angle theta. Use tip 2 and 3. I divide the y component, which is 50 Newton, by sine 60 degree. So P is about 57.7 Newton. Once the resultant force is found, and I know Px is adjacent side relative to the angle theta, use tip 1 and 4. Now, let's see how to calculate moment. Moment has 2 different levels of definition: algebra base level and vector base level. In two-dimensional case, we only need to know algebra-based level. Vector-based level is useful in 3-dimensional case, and I will make another video for it. In algebra-based level, moment is defined as force times distance times sine of the angle between them. Here I have a free body diagram. Currently, it's statically stable. But what if I apply a force P at point A? The moment of force P makes Planck has tendency to rotate about B. What does each turn in moment definition mean? In the equation, force refers to any forces presenting in the free body diagram. Here we have 4 different forces, which means there are 4 different moments. Distance refers to the distance between the point where the force is at and the axis of rotation. In two-dimensional case, the axis of rotation appears like a point. In this case, it's point B. Angle is measured between the forces and distances. In this case, they are all 90 degrees, and sine of 90 degrees is 1. Lastly, but not the least, we usually use right-hand rule to determine the sign of the moment. Let me use applied force P to demonstrate the right-hand rule. Here is my right hand. Make sure all fingers are towards to the direction of the force P, and the palm is facing the point of rotation. Now raise your thumb up. If the direction of the thumb is towards to you, the moment is positive. Otherwise, is negative. You can also imagine your hand as an arrow rotating about B. It is positive if it's in a counterclockwise direction, and a negative if it's clockwise direction. Let's do some practice. Example 1. Write down the moment equation. Calculate the moment of P about A. P is 50 Newton at point C. Distance between C and A is shown. Angle between force P and point A is 30 plus 45, which is 75 degrees. Thus, the moment of P about A is... Now, calculate the moment of P about B. The distance between C and B is 10 centimeters. Angle between force P and point A is 30 plus 90, which is 120 degrees. Thus, the moment of P about A is... So, how do you like the video about decomposition of forces and moments of forces? If you think you have learned something, please give this video a thumbs up and subscribe to the channel if you want to learn more about statics in the future episode. Again, the content in this video will prepare you for using equilibrium conditions in statics. I'm going to show you the ultimate guide to use equilibrium conditions in the next video. Stay tuned, and may the force be with you. Peace.